All right, I'm just going to show you quickly how to import data when you're running a model with individual covariates and show you how to plot. And I'm just going to use the INDCOV data set that they use in the MARC book. I don't have any weight data for the Swainson's thrush. But this will give you an idea of how you read it in. So you take a look at the file. We've got the 8 sampling occasions followed by one grouping variable, which is just all ones and we have to do it that way for individual covariates, followed by mass and mass squared for each individual. Okay, so we want to bump up the occasions to 8, groups is 1, covariates is 2, enter the names. Whoops. Mass and mass 2. Okay. And click OK. Say yes, that's what we want to do. We want to open this. And I'm just going to run the phi dot like they did in their example, just to get us a model to work with. Okay, so there we go. Let's take a look at it. Now, this is strange. Why would it give me 7 for each? I told it, and it's saying 2 parameters. So something a little funny here happened before. Well, I'm just gonna make this constant and this constant, and then renumber with overlap. So now we have our phi dot p dot model, and I'm just going to run that. Not sure why it didn't run that model before. So, oops, I didn't do an open parens there. Okay, so just click OK to run. Yeah. Yes. We should have 2 models that look exactly the same. Here's the one I just ran. Delete this one. Let's make sure. Okay. Yeah, so there we go. Phi dot P dot. And now I'm going to open a reduced design matrix, and I'm going to first run the model with the intercept, mass, and mass squared for phi, and the dot model for p. So I want to have 4 columns for all of those parameters. So for phi, we're just going to have 1. And now you click on this next cell, you right click, and you come down to individual covariates, and we say mass. Okay, and I'll just do what they did as well, and we'll come down and stick in mass squared, and run it, and then we have just a 1 for p. So when we run this, we can refer to this as p. Oops, phi mass 2 p dot. All right, okay to run. Boom, and we get it. Say append to output, and it says check parameters. I'm not sure why it's given an O, because for mass, yeah. So for mass squared, because the values for mass squared are really big, almost by definition, the beta term is going to be quite small, and so MARC may have trouble converging on that, and it's giving us a warning, but it actually is fine. It's 4 parameters, and that's what it should be. And just to show you the plotting for individual covariates, very slick. You can have to choose on the parameter to plot and the parameter to use for your x-axis. And this is, as Gary and Evan pointed out, this will give you kind of, quote, the wrong plot because it doesn't realize that mass 2 is the square of mass, and so it's not going to incorporate mass 2 into this plot. So what we want to do then is we can modify this one, and instead of typing putting the individual covariate that was in the data set that we read in, we're going to use the power function. So we just type power, open parentheses, mass, and then comma 2. And that tells Mark that the parameter that we're, or the values that we're using here for estimating our beta 3 are the values from mass squared, okay? And so now it knows there's a relationship between those two parameters, and when we run it, we'll get exactly the same. And I'm just going to indicate here that I use the power function and click OK to run. Yes, you can append it. All right, so as we talked about, these are exactly the same models. We can look at the phi and p. Well, probably more informative to look at the betas. Okay, minus 2.04, minus 1.9. Look at this one. That's 2.5. So yeah, the beta parameters are coming out exactly the same. And if we plot this now and use mass, it's going to know that the beta 3 is mass squared. So when we plot it, it's going to give us the quadratic relationship that we expect to see. Okay. Trying to think if there's anything else I wanted to show you. I think that pretty much covers it. Oh, the only thing, let's see, when we run the models, I won't actually run, I'm not going to run this, but they talked about some of these check boxes that you can check or not check in running models with individual covariates. You can ask Mark to standardize those individual covariates. You can say, do not standardize the design matrix. Talked about what that means in the lecture. And then you have 3 different options for, giving Mark the X values, the values from the design matrix, for it to use when outputting the estimates, the real estimates. So yeah, I'll go ahead and do this. And I'll just indicate that this is different by first encounter. Generally, you're not going to want to do that unless you set up the data so that the first encounter, that first individual has the values that you really want to use when you're estimating your parameters. And I'll just show you that, again, it's exactly the same. The betas are going to be the same. So minus 2.5, 0.04, and so on. Okay, but when we look at the real estimates using the mean value for mass, we get 0.59 for phi and 0.7 for p. Okay, when we use the values from the first encounter, you get 0.06 for phi and 0.0729 for p. Okay, and the mass is slightly different. See, that's 129, and on this one it was 109. So yeah, fairly different. And again, generally it makes most sense to use the means, but there could be situations where you don't want to do that. All right, I think that about covers it.